Hello, I wanted to talk about a subject that a lot of students have difficulty with, which is dividing fractions. To start out, what does it even mean to divide? I want to show this representation of dividing 40 by 10. And the way I want to do that is thinking about how many times does 10 fit inside of 40. If I have one 10 inside of this rectangle that represents 40, then it's going to be filled about this far. If I put in a second 10, then I have 20 inside of 40, and it'll be filled about this much. A third 10 is equal to 30, and then I will be filled most of the way. And then a fourth 10 gives me 40. And so 40 divided by 10 is 4. One of the ways you can think about this is if I have a classroom of size 40, so I have 40 students, and I split them into 10 or into groups of size 10, how many groups will I have? Well, I will have 4 groups of size 10. Another way you can think about it is instead of 40 students being split into groups of size 10, you can think of splitting them into 10 groups. This is the same answer, right? It's just slightly different representation. We get groups of size 4, right? And so we get the same sort of result here if I split this into 10 equal groups, each of them being of size 4. Now this representation is a little harder because you have to know how big this number is before going into the division problem, and which is why I like this representation a little bit better and is what we're going to do when we're getting into dividing fractions. So let's say I have 4 and I want to divide by 1/2. If I put in a 1/2 inside of this box that represents 4, then this box equals 4. I put in 1/2. It will be filled about this much, because I only have 1/2 inside of my box. If I put in a second half, 2 halves make 1 whole, so put those 2 halves together, and I have 1. If I put in a third half, oops, that's a 1/3, I want a 1/2. Then I will instead have 1 and 1/2. A fourth half will give us 2. A fifth half will give us 2 and 1/2. A sixth half will give us 3. And then finally, a seventh half and an eighth half will give us 4, after stopping at 3 and 1/2 in the middle. So 4 divided by 1/2 means that I need to use 8 halves to fill in the 4. And since I'm asking how many times does 1/2 go into the number 4, I get the number 8. Now, what if I don't use a half? What if I use a different number, right? If I take 4 and I divide it by 3/8, how does this work? What am I going to get? Well, if I put in 3/8 to start out, I have 3/8. If I put in a second 3/8, then I now have 6/8. If I put in 2 more, then I will have 2 more 8s. Then I will have 1 whole. But I don't put in blocks of size 2/8. I put them in size 3/8. So after I have 3/8 here, that's 9/8, which 8 fits inside of 9 one time, and we're left with 1 extra 8. If I add 3 more 8s on top of that, then I have 1 and 4/8. If I continue with this, another 3/8 is going to give me 1 7/8. If I put in another 8, or 3/8, then I will have 1 10/8. Which again, 8 fits inside of 10 one time, so I now have a second whole unit, but I have 2 8s remaining. If I put in 3/8 here, then I will have 2 5/8. Another 3/8 is going to give me 2 8/8. Well, we know that 8/8 is one whole, so we actually just have 3. If I put in another 3/8 here, what will I have? I will have 3 3/8. If I put in one more 3/8, oops, that bar is a little incorrectly placed. I'm gonna here. 3/8. Then this 3/8 here will be 3 6/8. Now, this final slice here is not 3/8 wide. It's actually a slightly smaller number. Now, the value in here, because if I were to put in another 3/8, then I would actually have 3 9/8, which we know is 4 1/8, because we saw 9/8 already being 1 1/8. So adding an extra 1 to the 3 gives me 4, with 1/8 left over. Now, this is a problem, because I can't add in another 3/8 in here. But I can add in a slightly smaller amount. And it's going to be a fractional amount of the 3/8 that I'm going to add in. So I need 2 of my 3 parts of the 3/8. So this last representation here needs to be 2/8, which is 2/3 of 3/8. Now this is important here because I want this whole thing to equal 4. Now, this last one is 2/3 of a 3/8. So how many 3/8 do I have? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 3/8, and then I needed 2 8s more, which is 2/3 of the 3/8 I was trying to fit in. So my answer here is going to be 2/3 on top of the 10. Now, what how does this work? Right? I've got 10 2/3. Right? What's another way of representing this? Well, 10 is 30/3. So this is actually 32 out of 3. Right? Now, I usually prefer to deal with fractions in their improper form, their unreduced form, rather than mixed fractions here. Or not unreduced, but unmixed here, where we've got whole numbers and proper fractions. So is there a way we can look at this fraction here, and instead of thinking how many times does this fit in to the problem, and I can get this number here, 32/3. Now, there's one other way I want to think about dividing numbers, which is what happens if I take the number 40, because my box is going to be representing 40 here. What happens when I divide by the number I have? If I divide by 40, what am I going to get? Well, I can put 140 inside of the 40, and then the box is full already. So 40 divided by 40 is 1. So I want to bring back the representation of multiplication that we've talked about previously, which is if I have a number, let's say that this is 5/7, and I want to multiply by another fraction, 7/5, then what do I do? In a previous video, I showed a way of representing a fraction as being a rectangle at the top and then a rectangle on the side, and then you create a square from those, right? So make sure to check back on my channel for that other video. However, the end result here is that we just simply multiply across the top and then multiply across the bottom. So 5 times 7 is 35. And 7 times 5, well, that's just the same number, 35. And we just talked about fractions as being division problems. So this is 35 divided by 35. Well, 35 divided by 35, we just talked about that as being equal to 1. Because if I take one number and I divide it by itself, I'm going to get 1. Then, if I'm dividing a number by itself and I get 1, then 5/7 times 7/5 is equal to 1. Then this multiplication is the same as division, because if I take 5/7 and I divide it by 5/7, I'm also going to get 1. So notice the difference here. If I'm dividing 5/7 by 5/7, then that's the same as multiplying by 7/5. I get 1 in both cases. Now, is this something that we can expand to, not this one here, this one, right? Can I do the same thing here, right? Well, if I have 3/8 and I want to divide by 3/8, then the 5/7 representation had it as being multiplying by 7/5. So this must be the same as taking 3/8 and multiplying by 8/3. And, well, we see that 3 times 8 is 24, and 8 times 3 is also 24. So that must equal 1, so this must be the same as dividing by 3/8. So if I take the number 4, or 4 whole units, so dividing by 1, and I want to divide by 3/8, then this must be the same as 4 divided by 1 multiplied by 8 divided by 3. Well, what happens when I do this? Well, 4 times 8, multiplying fractions straight across the top, straight across the bottom, 4 times 8 is 32, and 1 times 3 is 3. And this number here should be familiar, as that's what we said we had up here. 10 is the same as 30/3, and I have 2 extras. So I have 32/3, which is what I got here from multiplying the flipped over version of the fraction. Now, if you want a vocabulary term here for this idea here of flipping a fraction over, then this is called a reciprocal. These are reciprocal numbers, right? You flip a fraction over and you find its reciprocal. Now, when we're dividing fractions, note that the first number stays the same, right? This 4 that we talked about previously, divided by 3/8, when we turn this into a multiplication problem using the reciprocal, it became 4 times 8/3. And so we're going to keep the first number, change the sign, and then flip the second fraction. Right? Some of my students refer to this as keep, change, flip. And so this is the same as whether or not this 4 is a whole number or if it's another fraction. So let's say I had 6/5 and I wanted to divide by 3/8. Well, that's the same as 6 divided by 5. We keep the first number, change the symbol into multiplication, change the operation to multiplication, and we flip the second fraction, 8/3. 6 times 8 is 48, 5 times 3 is 15, and then we get our final answer here. Now, it's always important to check if this fraction reduces. 48 and 15 both share a factor of 3. If I were to divide 48 by 3, that would be 1/6, and 15 divided by 3 is 5. And so we know that from our multiplication that there must be a shared factor between the numerator values and the denominator values, which we see that this 3 here, if we divide that out, cancels with a 3 from the 6, leaving behind a factor of 2 and a factor of 1. And so 2 times 8 is 16, and 5 times 1 is 5. But you can always reduce the fractions at the end if you do not see the shared factors in the multiplication problem at the previous step. All right. I hope this representation of division and how you get to reciprocals makes a lot of sense. If you have any questions, put them in the comments below. If there are other topics you want me to cover, also put those in the comments below. I hope you have a good day, and bye for now.